In question 2, you were presented with 4 equations and asked to solve them. And it also says verify that your answer is a solution. That's a great way of just checking whether or not you made a simple mistake. Just plugging in the value of x you get and seeing that it does indeed make the left and the right hand side the same. So let's start with question A. I'm going to begin this one by rewriting a part of it using the simplest form of the distributive property. You can see I have a positive 5 here, and I'm going to multiply or push that factor of 5 across these two terms. So both the x and the negative 5 are going to pick up factors of 5. So I'm multiplying both of those by positive 5. So far I'm just going to copy down the negative 2x, but then I'm going to rewrite a part of it as plus 5x minus 25, and that equals 5. So this thing that I'm underlying needs to be equivalent to the thing that I rewrote below. And it is. I can verify that with an area model if I want, but I don't need to in this case. If I combine negative 2x and 5x, that's exactly 3x. So I have 3x minus 25 is 5. Let's see that, and again, that's an example of rewriting as well because I rewrote these two like terms together as a single term. Now I'm just going to use the addition property of equality and add 25 to both sides. So I get that 3x is 30, and the division property of equality tells me that x is 10, and that's me dividing both sides by 3. Now as a verification, if I bring positive 10 up here, negative 2 times 10 is going to make negative 20. If I put 10 in for this x, 10 minus 5 is negative 5. No, 10 minus 5 is positive 5, right? 10 minus 5 is 5. 5 times 5 is 25. So this becomes negative 20 plus 25, which is exactly equal to 5, which is what the other side was. So I can see when I put 10 in, it makes both sides the number 5. So this is a solution, and it checks. Let's move to B. In B again, I'm going to use that simplest form of the distributive property, where I'm just going to distribute this multiplication by 2 to both the x and to the positive 6. So that's going to become, on the left-hand side, 3x plus 12, and that will equal 2x plus 12 plus an additional x. When I combine this x and the 2x, I can see that both sides become exactly 3x plus 12. Now, when that happens, right, when I see that they become exactly the same, both positive 3x, both positive 12, I know that the value of x I select doesn't matter, right? In fact, I could take away 3x from both sides and I get a statement that is always true. 12 is equal to itself. When I see that happen, I know that what I'm looking at is a situation where all real numbers are solutions. So I'll just say all real solutions, or all real numbers. Some of you saw this and you wrote infinite solutions, and that's not false, but I didn't ask you to tell me how many solutions there were. I asked what the solutions are. So when you tell me all real numbers are solutions, that's telling me what the solutions are as opposed to how many solutions. So that's B. Let's move on to C. In C again, we see an opportunity to rewrite a part of this using thing called the distributive property. So I'm going to distribute this factor of 3, oops, go away, to both the 2x and the negative 5. And when I do that, that's going to become 6 times x minus 15. And then I have an opportunity to distribute again this negative 2 times both the x and the negative 1. So I'm trying to make sure that I'm picking up the signs as well. So when I do that, I'm going to get negative 2x and then plus the negative 2. Then there is a plus 5, and on the other side of this, it was equal to 12. A couple like terms here. I can combine 6 times x and negative 2x, and that becomes 4x. And then I have this negative 15 and positive 5, which would be negative 10. And negative 10 plus 2 would be negative 8. So this equation is going to become 4x minus 8 is 12. The addition of property of equality will make 4x become the number 20. And if I divide both sides by 4, x will be the number 5. Again, it's super nice to plug that value in and verify that it is indeed a solution. If I put a 10 in, I'm sorry, not a 10. If I put a 5 in here for x, this is going to become 2 times 5, which is 10. 10 minus 5, which will be 5. 5 times 3 will make this part 15. So I have the number 15. And then over here, when I put in 5, this is going to become 5 minus 1, which is 4. So this is going to become a negative 2 times 4, which is negative 8. And then you can see then there's a plus 5. If I combine this negative 8 and this positive 5, that becomes a negative 3. And yep, sure enough, you see it. 15 minus 3 is exactly equal to 12, which is what it should be, right? So when I plug in x is 5, it makes both sides of that equation equal to 12. So x is 5 is our solution. And then finally for part D, there's another opportunity to practice this simplest form of the distributive property, where I'm just going to multiply the 2 times the x and the 2 times the positive 4. When I do that, I get 2x plus 8 minus a value of x equals 10 plus x. On the left hand side, I can combine those. That's going to become x plus 8 equals 10 plus x. Now this is a problem because you can see that they're not exactly the same. However, they have exactly the same single value of x on each side. So if I take away x from both sides, this is what I end up with. So this is a problem because regardless of what I would have selected for x, right, because it would have been the same value on each side, there's nothing I could have selected for x that would have made this true, right? 8 is never the number 10. So when I get a contradiction like this, which is stating that 8 is 10, right, I just have to say there is no solution. So that's what I would write for D. There's no value of x that's going to make 8 be the same thing as 10.